Section 6.6 is all about different proportionality theorems. We are still going to be setting up the same proportions and cross-multiplying the same way we've been doing throughout the chapter. There are 4 different theorems that we are going to learn, and we're going to look at 4 different types of problems that you will see both on your homework and on your test. So our first one is called the triangle proportionality theorem, and it says if a line is parallel to one side of a triangle, intersects the other 2 sides. So we can clearly see here TU is parallel to QS and its intersecting side QR and SR. It says it divides the 2 sides proportionally. So when we're going to set up our proportion, we're going to look at our first side. So here's our one side and our 2 segments that are split into RT over TQ is going to be equal to the proportion of my other side. So RU over US. Similarly, we have the converse of our triangle proportionality theorem, which says if we know that the side divides if we know the line divides our 2 sides proportionally, then it has to be parallel. So if I get the same proportion when I do RT over TQ as I do when I do RU over US, then I am proving or showing that TU has to be parallel to QS. So now we're going to practice problems here. So it says QS is parallel to UT, and we can see that it is clearly marked here with our arrows. It gave us RS was 4, ST is 6, and QU is 9, so it's all labeled for us. If it wasn't, I would fill in those numbers. It's asking us for the length of our Q, so I'm going to label that as X. That is our unknown. So when we're setting up our proportionality theorem, we're going to look at one side at a time. It's almost like we're covering up the other side. So I'm looking at side RU, and my 2 pieces that I have formed are 9 and X. It doesn't matter which one you pick to go on the top. I'm going to say X over 9. I just have to be consistent now when I'm setting up the other side of my proportion. So since I said X over 9, when I'm looking at my other side, I have to make sure I do 4 over 6. If I had set up my proportion the other way and done 9 over X, then I would do 6 over 4. Now when we're going to cross multiply to solve the proportion, so I cross multiply and I have 6x equals 36. When I solve, I get x is 6. Now, in our second problem, we are asked to determine whether or not PS and QR are parallel. So we can see it gives us all 4 values already, and we need to check, are the sides proportional to one another? So again, I'm going to look at one side at a time. So I'm going to look at QN. So I'm going to see, does 90 over 50 give me the same ratio? And I'm going to be consistent. I did 90 over 50. I'm going to do 72 over 40. So I have all my values. So I'm still going to cross multiply, but we're going to see if we wind up with the same number. So I get 3,600 equals 3,600. So if we get the same value there, we would say yes, PS is parallel to QR. If we would have gotten a different value, then we would conclude that they were not parallel to one another. So now we're looking at our third theorem and our third type of problem that we are going to see. So this one deals with 3 parallel lines. So I can see R, S, and T are my 3 parallel lines, and they're being cut by 2 transversals, M and L. So it says, this theorem says that the transversals will be divided proportionally. So again, we look at one transversal at a time. So if I'm just looking up transversal L, I can see my 2 segments that are formed are UW over WY. So I'm just going to rewrite what's already there. But UW over WY. Now I'm going to follow suit when I look at the other transversal. Now I'm going to say VX over XZ. So now we're going to practice that theorem. So we are asked to find the length of AB. So I'm going to label it as X. Again, when we're going to set up our proportion, we're going to work on one line or one side at a time. So I'm going to look at my 16 and my x. I'm going to choose the 16 first. So if I say 16 over x, then when I'm setting up the other side, I'm going to make sure I'm consistent, and I'm going to do 15 over 18. So again, in our next step, this is where we cross multiply, and I get 15x equals 288, and then when I divide by 15, I get x equals 19.2. Now, our fourth theorem, so our fourth type of problem that we should be prepared for, I think is the trickiest. So this is probably the one that I would spend the most time kind of reviewing and looking over. So it says if a ray bisects an angle of a triangle. So we will be able to tell that it's a bisector because we can see here they have marked the two angles as being congruent. Then it divides the opposite side into segments. So I can see it split side AB into two pieces. So it split them proportionally. So I wrote my ratio of AD over DB. So it splits that side, so it's proportional to the lengths of my other two sides of my triangle. So since I said AD over DB, now when I'm comparing my other two sides, I'm going to pick the one that's connected to AD first. So I'm going to say CA over CB. Another way we could have set up this proportion is if we decided to originally go with BD over AD, then when I was choosing my other side, I would say CB over CA. Again, it's just you have to keep it consistent when you're setting up your proportion. So now we're going to practice one of these problems. I can see I have a bisector. It's going through here. So when I'm setting up my proportion, trying to find the length of AB, I'm going to mark it with X. So I first start with my side that's been split. And for this one, since we have the same value, I wind up with 4 over 4. It's kind of hard to tell which 4 you pick first, so I'm just going to mark, I picked this 4 first, so then I know I'm going to have 4 square root of 2 over x. Now we are going to cross multiply. So I get 4x equals 4 times 4 square root of 2. It's going to give me 16 square root of 2. Then when I divide by 4, I just wind up getting 4 square root of 2. So some of you may have seen the answer already because I have 4 over 4, which simplifies to 1. So we could probably already figure out that x has to be 4 square root of 2, but I just wanted to show you how to set up and solve this proportion. Okay, so we're just going to practice 2 more of our last 2 theorems that we talked about because these are the ones where I often see more difficulty arising. So for both of these problems, we're trying to find the length of AB. So for our first problem here, I'm going to mark AB with an X. So this is one where we had our 3 parallel lines being cut by a transversal. So we're setting up a proportion here. I'm going to look at my bottom transversal first. So my 2 pieces were 40 and X. So since I did 40 over X, when I'm doing the other side, I need to make sure I do 35 over 21. So as usual in our proportions, we are going to cross multiply. I get 35x equals 840. When I divide by 35, I find out that x is 24. Our last problem that we have here is dealing with our angle bisector, because I can see that the 2 angles are congruent, so that means I'm going to start by setting up a ratio of the 2 segments that are formed here by my side AC. So I'm going to say 52 over 20 equals, and since I said 52 first, that means I'm going to use this side first. We don't know it, so I'm going to say x over 30. So when I cross multiply, I get 20x equals 1,560. And when I divide by 20, I get x equals 78.